So these explorations are mainly to get you looking at notation. All right. So it's also, do you remember like that paper I gave you as an assessment that time where you have to follow the steps and look at what it's doing and then just work from that point? Remember that? So it says we've got two sets of data. All right. So I've got 2, 4, 4, 5, and 7, and I've got another set of data. It's 4, 6, 9, 10, 11, and 14, and it says find mu, the mean of the population. So that's population 1. This is population 2. So what's the mean of it? 4.4. And how did you do it? Just add them all up, divide by 5. So the mean of population 1 and then the mean of population 2 is 9. Can I just ask you why the mu and not the x bar?
Because the x bar is like the coordinates on the graph.
There you go. So you've got x bar, y bar when you specifically wanted to talk about coordinate points on the graph. When we're just using mean as a mean, we can use that mu symbol. So that's why we've got more than one option. Okay, so that's the mean. And then it says find for each one it says the mean of the squared values. So the squared values would be 4, 16, 16, 25, 49, and this one would be 16, 36, 81, 100, 121, and 196. So what would mu1 squared be? Pardon? 22. Okay. And mu2 squared? 91.6. Okay. Just rounded it. Alright. Now the next bit just says generalize your findings. So it's saying, based on what you've just done, the process that you've gone through, it says if mean, this one, is written as that, what does that mean? Yeah. Yeah. So take all the x's, add them together, and divide by how many x's there are. That's what that means. So it then says, well, what would this one be? Yeah. It's not an E, it's a sigma. Don't need brackets. Sum of x squared, and then divide by n. Simple as that. Right? Nothing different from what you just did with the numbers. It's just about being able to write it. It's just what this task is doing is getting you to look at how we use this notation. As the next exploration involves you being able to just be happy with that there's a sigma there and what it means. Right? So sigma means just add it all up, yeah? So sigma x means the sum of all the values, and sigma x squared means the sum of all the values squared. I should rewrite that one though, shouldn't I? I don't actually like that. That's a bit ambiguous. Why?
I was going to say because it could be negative, but that doesn't work. That's square root.
No. Just with the wording.
Because you can interpret it in 2 different ways. Either all the values squared is the sum of the squares, or it's the sum of the value of the square.
Yeah. Do you all see that? Are you all paying attention to this point? Yeah? This could be ambiguous. It could mean exactly what I want it to mean. Square the values and add them all up. It could equally mean sum the values and then square that answer.
Well, isn't that why you want to put it in brackets so you know?
But do I use brackets in my worded statement?
No.
No. So I'm just going to, it's just a bit of language so that when you're writing things in reports, you can think, as if you're thinking about how the words are written, you're actually thinking about how the maths is being done as well. So how can I rewrite it so that I know it's this one? So I could go on.
Sum of all the values and then square? Or square?
No, because that's wrong, isn't it?
Oh, that's the bracket one.
What?
Sum of squared values.
Oh, yeah, all right. Sum of
All the squared values.
all the squared values. That would be better, wouldn't it? Yeah? Now I know that one, I'm happy with. So be careful how we write things in words as well as. Okay. So you can now do questions 6 and 7. Have a go. All right, can I just ask you something then? Let's go back to up here. When you worked out your means, what did you do? Zoe, you with me? What did you do? Working out the means. You've already told me once, so the first means, just M1, M2. Add them all up. Right, can I ask you what I write now for adding up all the numbers? So sigma x. So what is sigma x for this list of numbers? 22. Okay? Then sigma x divided by n is 22 divided by 5, which equals 4.4. This one, now I'm going to call this x1. This will help us for the next bit. And then this one, I'm going to say is x2. What's the sum of those numbers?
It's 54.
54. Then the sum of x2 divided by n. So I'm going to call this n1 and n2. So that would be 54 divided by 6, which equals 9. Okay? Right, now that's why I said, because for this next question, it says work out the combined population. So the first step is to do what? Add up all the numbers, yeah? Add the two populations together. Now I'm kind of hoping you'll have gone, all right, okay, well, the sum of the first numbers is 22 plus 54. That's why I said you don't have to rewrite all the numbers and add them all together separately. And that's what helps us with the sigma notation at the end. And then I divide it by 5 plus the 6, because there's 11 numbers. You with me, Ethan? Not you, yeah. Don't apologise, not your mistake. That gives me 76 divided by 11, which equals 6.909, is it? Okay, so that's it. Now, is that the same number as adding the two means together and dividing by 2? No. So that's one thing to realise. You can't just combine two population means, add them and split them into 2. All right? Doesn't work that way. Unless they're the same size population. Right. How can I express this then in sigma notation? So by the way I've done this, should now be relatively easy.
Sigma bracket x1 plus x2.
Oh, sorry.
Divided by n1 plus n2.
See, I would have gone straight for, and we'll discuss this. I would have gone just that. Are they equivalent? Would they give me the same thing? Right, but what about the notation on the left-hand side? What does x1 plus x2 mean?
The numbers in the population 1 and the numbers in the population
And then the plus in the middle?
2. You add them.
So why do I need the sigma on the outside? Is that a bit... I get exactly what you mean. It's that distributive law thing, okay? But would I write it in this way? Go on.
I don't understand why the sigma is useful, like in this case.
It just means it's a way of communication. So you should be latching onto this and thinking, criterion C, right? How do I show different forms of communication? All right? Plus, you have to understand how other people have communicated with you. So if you're given a formula with a sigma, okay, it's saying that x1 here is not a single value. Right? It's the sum of all x's in the population, yeah?
Both these things might mean the same.
Well, that's the thing. This one here, I'm kind of looking at that top line and going, would that be an appropriate way to write it? Do you understand this way round?
Yeah.
Yeah? Add up all the x1s, which is what we did here. That's the sum of, sorry, I'm writing these now. That's the sum of the x1 values, the population 1. This is the sum of the population 2. I've added those together. This is the number in population 1, and I've added that to the number in population 2. Okay? How would this work? What would I do if I were to replace those with the numbers?
Yeah, you add it up and then it would be the
Well, what
sum.
what would I do? x1 plus x2. What would I actually do?
Add up the population.
Would I though? Is that telling me to do it?
It's telling you from some of the added up populations.
It's not. x1 here, now that means the sum of all the x values in population 1. What does x1, because it's inside brackets, so I have to deal with it first. What does x1 plus x2 mean?
So, no, all the
All
the values.
in
No,
population
you know in your head that's what you want it to mean. But if someone to write that to you and you didn't know what it meant, you just had to work with it, what would you do? Add up two values. A value in a population 1, and I would add a value in population 2, and I would keep doing that, and then afterwards add them all together, yeah? That makes sense? So I would kind of do this. This one here makes me think I would do 2 plus 4, 4 plus 6, 4 plus 9, 5 plus 10, 7 plus 11. But then I'm missing the 14. But then I've got to add all those results together. Do you see how? So this notation here, I understand it, where you're coming from. But do you see how it's a little bit maybe confusing? Whereas just keeping it separate like that works, doesn't it?
Yeah.
Add up all the values in population 1, add up all the values in population 2, add them together. Yeah? So this is, like I said, just about getting used to using sigma notation. So we'll kind of avoid that. Now, saying that, having a look at exploration 4, okay, do you notice that the first formula that you're given, do you recognise that as the standard deviation formula? Kind of. Would you like to explain it to me again? So remember, it is standard deviation is the square root
of the sum of
The sum of
the x values minus
the
the
mean squared over the number of values.
Okay, so Kieran, you had your hand up. Go through the steps of that. Do you want to explain?
So first, you so
Now I want to know where that comes from, not how I use it. Do you remember how we built it up? Think of what standard deviation is.
First you find the difference between all the x values and
Yeah, so how far are all the values away from the mean value? That's the subtraction bit. Then you,
square them.
why?
Because they might end up being 0 if
Because some will be
negative.
negative. Some will be negative, some will be positive. So we square them so that when
All
we
positive.
add them all up, we don't end up with something close to 0. We then divide by,
The number of values.
so summing something up and dividing by is basically doing the mean. And then we square root finally because
We want to get back
to
to
negative numbers.
no. We want to get back to like the
original.
originals.
what
In a
original?
sense.
What was
In
the
a sense.
specific?
Back to
The original.
Value.
No, we're not going to get back to the original. We're going to get standard deviation and we're going to get square root to get rid of the squaring. But there was one reason which justified that to us.
actually using
That's it. You said go back to the originals, but what I wanted from you was go back to the original units. So if all the x values are in centimetres, if I square them, they become centimetres squared. So I have to square root them at the end to go back to centimetres to have my standard deviations. Centimetres. Did anyone remember what it was called before you square rooted it? So that's the standard deviation. This one here was without the square root. Do you remember what that was called?
Square standard deviation.
Standard deviation squared.
Complex root. It was called
Variable
what? Just variance. Okay? The variance is the spread before you go out. That was all it was, right? I would like you to have a go at exploration 4 for me. It's just about algebraic skills. Follow the steps. Okay? When you get to point 5, be very thorough. Say it again.
what do you need to do for step 1?
Write down the formula. I've done step 1 for you.
Wait. So it just wants me to write down what's right here.
Yep, it wants you to, it gives you step by step, it just wants you to fill in the squares.
Okay.
What should be in the squares? It's very prescriptive, it's just testing your ability to do it. So if you want to expand this bit, it's like having, well, we're going to do the sum of x minus mu times x minus mu again. That's what squaring means, yeah? So do you recognise this as, let's say I have x plus 3 and x plus 2 as quadratics? Remember how to do that? You've done FOIL,
Yeah.
doing the same thing but with funny letters. That's all. When you expand this, did you do x times x is the x squared? Then we've got, so that's first, outsides, so minus, however you want to do it, mu x. Insides, minus another mu x. And then lasts should be plus mu squared. So we should end up with the sum of x squared minus 2 mu x plus mu squared. Still all over n and still square rooted. That was the first stage. Got that? Then